Okay, in this first unit, we're going to be talking about motion in terms of speed and acceleration. As we've talked about in class, speed you can describe by the displacement of an object or how fast something is moving. And speed is calculated as distance over a unit of time. Any change over time is called a rate. So speed is actually a rate, and it uses the formula speed equals distance divided by time. The typical standard is meters divided by seconds. As you can see, here is a list of the standard units of measure for speed. Typically things like kilometers per second, kilometers per hour, centimeters per year. You may have heard of other calculations like miles per hour when we're talking about vehicles in the United States. Speed is constantly changing. It's rarely ever constant. So if you look at this graph here, which is a distance divided by speed graph, you see when something is gaining speed quickly, when you're climbing a steep hill, so your speed is slowed down, you're going downhill, stopping for a red light, and you only ever see constant speed in one place. Average speed describes the speed of motion when speed is constantly changing. So you take up your total speed over the entire trip and you average it. And that's most of the time we talk about speed, we're talking about average speed rather than instantaneous speed. As instantaneous speed shows how fast you're going at that exact given moment in time, which is very hard to do. Instead, we're looking at your speed over an entire trip, which is your average. Instantaneous speed is constantly changing. When you're speeding up, when you're slowing down, that's constantly moving. And you can plot that all on a distance versus time graph. You always put the distance on the vertical axis and the time on the horizontal axis. Velocity is the same thing as speed, only that it now includes direction. Because velocity depends on direction, the velocity of an object changes even though the speed may not. If the speed is constant, the velocity is changing if the direction of the vehicle changes. So if you look about this car going around the track, it could be traveling at a constant speed, but its velocity is still changing because its direction is changing. Acceleration is the rate of change of velocity. So it's how much your speed is changing. Are you going faster? Are you going slower? So it's a change in velocity when we talk about acceleration. So you're going to be using two different velocities, your starting velocity and your ending velocity, to calculate acceleration, since we're talking about a change in velocity. So you're going to take your final velocity minus your initial velocity and divide them by time. So this concept of acceleration is all about a change in your velocity over a certain period of time. How is the acceleration for an object that is speeding up different from that of one that's slowing down? Well, if we have the jet airplane on the track waiting to take off on the runway, and it's going to gain speed up to 80 meters per second, so it's starting at the end of the runway, sitting and waiting to take off, so its beginning velocity is 0. As it takes off down the runway, it reaches a speed of 80 meters per second, which would be its final velocity, divided by the time it took, which was 20 seconds. The airliner is speeding up, so the final speed is greater than the initial speed, and the acceleration is positive. But if we're talking about somebody going or slowing down, so they were going 3 meters per second and stopped, so their final velocity was 0 because they stopped, and their initial velocity was 3 meters per second. Divided by 20 seconds, that would end up being negative acceleration, and a negative acceleration